Alright, let's take a look at some of these sample questions. We'll look at questions from 4.1 and 4.2. They may be two separate videos, but we'll see how long this takes. So, I'd encourage you to pause the video anytime you can and take down notes, write down the questions, sketch things out, and then start it up again when you're ready to go. So in this first question, we're going to sketch each angle in standard position, and then we'll convert degrees to radians, or vice versa. If we've got questions in radians, we'll convert those to degrees. And we want to express answers in exact form if possible. Typically, that's referring to degrees and changing the degrees to radians. That's when we're going to be looking for exact form if possible. So we don't want you just to plug into your calculator and get some decimal number. We want you to have an understanding of what fraction this is of pi. So in the first case, we'll draw in standard position. So we've got 60 degrees. Now we know that this is 90, or 0 degrees. This is 90. This is 180. So 60 is going to fit somewhere up in this first quadrant. And 60 is 2/3 of 90. So it's not going to be halfway here, but it's more going to be like this, somewhere over here. And what I showed you in class is to get a sense of breaking the space into 3 equal spaces. So this might be 30, 60 degrees. So standard position, we've got our terminal arm here at 60 degrees. The second step is to convert the degrees to radians. So we saw back in the notes that 180 degrees is equal to pi radians. And we use that concept to convert degrees to radians. So we take whatever our degree measurement is and we multiply it by what's essentially equal to 1. Pi and 180 are the same thing. So we're really only going to change the look of this, right? We're going to change it to a different unit. When we do this, the 60 and the 180 can reduce. 60 goes into 60 once, and 60 goes into 180 3 times. We're left with pi, which gives us pi over 3. Which makes sense, because if 60 is 1/3 of 180, then pi over 3 is 1/3 of pi. And that's exact form. So let's do the same thing with 315. Again, I know that this is 90, this is 180, I'm getting ahead of myself, this is 270, and this is 360, or 0 degrees. They're coterminal angles. So 315 is going to fit somewhere in between 270 and 360. Now 315, that's 45 more than 270, and it's 45 less than 360, so it must go right down the middle here. And if I draw this in standard position, that means I'm taking my angle counterclockwise like so. So there's the 315 in standard position. And then I want to convert that into radians, so I'm going to multiply again by pi over 180. I'll figure out what goes into 180 and 315. And I saw over here that this was 45 less and this was 45 more. So I'm willing to take a guess here that 45 goes into both. And it turns out that it does. 45 goes into 140 or 180 4 times. And it goes into 315, I believe, 7 times. I have to check that out. And that comes up to 7 pi over 4, okay, in exact form. We've got the same question here, but now they're in radians and we want to convert them into degrees and put them in standard position. So remember that 180 is equal to pi radians, and 360 is equal to 2 pi radians. Anytime I want to mark some angle down in radians that has a denominator, I try to think of what pi would be with that same denominator. So pi with the denominator of 3 would be like saying 3 pi over 3. It means the same thing. And 2 pi would be like saying 6 pi over 3. That helps me visualize where the 4 pi over 3 should be. Right? If this is 3 pi over 3 and 6 pi over 3, then 4 pi over 3 is going to be over here, and 5 pi over 3 is going to be over there. So 4 pi over 3, right there, in standard position, that's my terminal arm. I don't need this one, I just used it to help visualize. Now to convert that into degrees, I'm going to do the same as previous questions, but instead of multiplying by pi over 180, I want the pi to cancel out, and I want to be left with something in degrees. So pi on top, pi on the bottom, 180 over 3, that's going to give me 60 over 1, and 4 times 60 is 240 degrees, which looks right. Right? This is beyond 180 and less than 270. For pi over 2, remember this is pi, this is 0, so pi over 2 is exactly halfway between them. So it looks like 90 degrees. If I multiply by 180 over pi, pi's cancel, and 180 divided by 2 is 90 degrees. Now before we go on, remember to pause your video if you need to, take notes, complete things, and then when you're ready, start up again. Now in question 2, we're asked to determine one positive and one negative coterminal angle for each given angle. So if I've got 262, I can get a coterminal angle. Remember that a coterminal is, if this was my terminal arm, it'd be going around a full circle and coming back to it. So it'd be like taking whatever the first angle was and adding 360 to it. So to get a positive coterminal angle, I'll add 360. And to get a negative coterminal angle, I'll subtract 360. So whatever those answers are, you can check them out. This one is already negative. And if I add 360 to it, it's still going to be negative. It'll be negative 45 degrees. So there's my negative coterminal angle, or one of the negative coterminal angles. But I still need to add another 360 to that to get my positive coterminal angle. So negative 45 plus 360 comes in at 315 degrees. Okay, so whatever it takes to come up with one positive and one negative. Now in radian form, instead of adding 360 degrees, we're going to add 2 pi radians. So I want to add 2 pi. But notice that I've got a denominator here. So in order to add, I have to have a common denominator. So if I want this to be over 3, I'm going to have to multiply top and bottom by 3 to get 2 pi over 3 plus 6 pi over 3, which will give us 8 pi over 3. And then I need to do the same thing and subtract 6 pi over 3, which will give us negative 4 pi over 3. And you can do the same thing here. We're going to add and subtract 2 pi, but because it needs a denominator of 5, I'll have to rethink of that as 10 pi over 5. So if I add it, I get 16 pi over 5. And if I subtract it, I get negative 4 pi over 5. So a positive and a negative coterminal angle. Now in this one, this is fairly straightforward. There's actually a little bit more to this question, but I just wrote down this last part. For each angle theta, determine an expression in general form for all angles coterminal with theta. Now, each angle will have an infinite number of coterminal angles. So we need to find, we can't list them all, so we look for a way to express them all simply. And that's what mathematics helps us do. It's a language that helps us express things more succinctly. Now we saw that with degrees, we needed to add multiples of 360. So if I added 360 or subtracted 360, okay, that would give us coterminal angles. So multiples of 360 will help us do that. I can add or subtract multiples of 360 as long as n is a natural number. If n is 1 or 2 or 3 or 4 or 5, etc., I can add or subtract multiples of 360. And that's it. For angles in radian measure, I'll do the same thing. I'll add or subtract multiples of 2 pi. And I show that by going 2 pi n, where n again is an element of the set of natural numbers. And that's all that's necessary. Now I might need to do some things if I wanted to find 2 positive coterminal angles and 2 negative coterminal angles. Here it's just, add 360, add 360 again, subtract 360, subtract 360 again, etc. Here though, I'd have to make sure that I rewrite my 2 pi with a denominator of 7. So what would the numerator be? Right? Hopefully you've got 14 pi over 7. All right, and next question. Determine the arc length subtended in a circle if the central angle is 2 pi over 3 and the radius is 30 centimeters. So remember that arc length, we've got a formula for that, where A is equal to theta times r, as long as our angle is in radians. You won't always see a pi, but you can't see like 57 degrees. So if you know the central angle, plug it in. If you know the radius, plug that in, and that's going to give us our arc length. So 2 pi times 30 divided by 3, or 2 pi times 10, or 20 pi. And if we want to write that in, let's say, the 2 decimal places, (62.8), let's see, 20 times pi, 62.83 to 2 decimal places, and that would be in centimeters, because our radius is in centimeters, so our arc length will be in the same unit. So those are a number of sample questions from section 4.1. If you haven't done so, I'd encourage you to look back at your notes, do some practice questions before class starts on Monday. Hope you had a great spring break, and I'll try to do one more video with some questions from 4.2.